part 4 of our electromagnetic induction lesson. So in the last lesson itself, we want to understand this device called cathode ray oscilloscope, and we want to be able to read this oscilloscope. Okay, so what is a cathode ray oscilloscope? Have you ever wonder how we can see voltage waveforms as discussed in the earlier chapter? Voltage waveforms are as like this. Okay, we can see this actually using a device, and this device is actually called an oscilloscope. Okay, a cathode ray oscilloscope, or what we call as a C.R.O. in the lab. So a C.R.O. is used to show how a voltage changes with time. It works by deflecting a beam of electrons in an electric field and consists of a vacuum glass tube. So this whole thing here is a vacuum glass tube. Okay, and in this vacuum glass tube itself, there is an electron gun portion. This is where the electron is being shot out. Okay, and at the same time, there is a deflecting system where it deflects electrons using electric field itself. Okay, last but not least, there's a fluorescent screen. Fluorescent means when electrons hit it, the screen will get certain excitement due to electrons hitting it and will produce a visible light that we can see. So this is how the setup is itself. Okay, so what happens? The cathode, we look at the electron gun first. The cathode here will emit electrons. How will it emit? By heating it up. So it will heat it up using thermionic emission. So when you heat up this cathode here itself, electrons are being released on it. Then you can accelerate these electrons towards the anode. The anode is here. So this is a cathode anode. Remember chemistry, cathode anode, electrons will move from a cathode to anode. Then by setting up the anode at a certain distance away, it will allow it to, they will generate an electric field, will accelerate these charges, give it a movement, and when it moves itself, it will move to the remaining path all the way to the fluorescent screen. You can adjust these dots itself by actually using the deflecting system. So when there are more electrons hitting the screen, the dot will be bigger, it will be a brighter indication on the fluorescent screen. Now, you can change the movement of these electrons by changing the voltage across the plates. X plate, so there are two plates. X plate allows the electrons to move in the X direction. The Y plate causes the electrons to move in the top-down direction. So we can allow the electron to sweep horizontally using the X plates by changing the voltage, or we can allow it to move in the Y plates by varying the voltage in the Y plate itself. So when you change the voltage, you change the electric field. You can actually cause it to be, you can deflect the electrons and you can manipulate the electrons. To find out more about using the C.R.O. or cathode ray oscilloscope, you can read up your textbook on page 442. What are the uses? Number one, you can use it to measure voltage. It can be used to measure voltage, yes. So you connect it yourself, you can measure how much voltage is coming out from whichever devices that you are using. Why? Because you just need to connect it to the plates itself. You'll be able to identify how far away it moves upwards, downwards, left or right. Okay. So when you measure a constant voltage itself, your time-based x-axis is off. So you're only using the y-axis to represent how high it goes or how low it goes. So the table below explains how this is work. So there are a few things here. There is time-based off and time-based on. Okay, so when your time-based is on itself, this is talking about the x-axis. Sorry, it's talking about x-axis. Your x-axis is this plate here. So this is used for your time base. Okay, so if your time base is on, your x-axis will play a part. If your time base is off, your x-axis will not play a part. Otherwise, it's only the y-axis that is playing a part. Okay, so when there is no input at the y plate, so your y-axis, so now when your y plate itself, we are talking of you connecting this y plate, you are controlling this y plate here. Whatever thing you connect to it has no voltage. Your time base is off, so all the electrons will just keep hitting the middle point. Okay. Next, when you have an input now, at the y-axis there, you input a 1.5 volts. You set a sensitivity of 0.5 volts per division. That means every of this division is 0.5. So how many divisions do you need? 1, 2, 3. So you need 3 division up because it's 1.5. 1.5 divided by 0.5 means 3 division. So your dot now will be up there and will always remain there. What happens if now you put a negative 2.0? So negative is downwards. And now your sensitivity is 1.0. That means it's 2 division down. Your dot will keep remaining there. So you can see that you can measure the voltage itself. Next, what will happen is now you apply 20 volts, but because it's alternating current, this voltage will keep changing because there's an alternating voltage. So one moment it will keep, sensitivity is 5 volts, is at 5 volts per division. So if you have 20 volts peak here, means you need 4 division either end because it's alternating, it goes up and down, it keeps moving up and down. Okay. Next, if you have 20 volts, 5 divisions, same thing, you also have 4 divisions. It's exactly the same method. Only difference is the hertz that we will explain now. So now your time base is on using the x-axis. Your time base has a frequency of 25 hertz. Assuming that your time base has a frequency of 25 hertz, it means that there is a x-axis movement. Your dot now will start to move and it will form a straight line. Similarly here, your dot above here will start to move and will form a straight line across. Your dot above at the bottom here will also move and form a straight line. Now what happens at the bottom? So if it's at the bottom, if it's 50 hertz itself, what will happen is it will move and form such that it will form 2 wavelengths. Why does it form 2 wavelengths here? First, we must understand the number of cycles is determined by Fy over Fx. What is Fy? Fy means the frequency of the AC input, which is here and here. So this is the input. What is Fx? Fx is the frequency of the time base. So what is the frequency of the time base? Here is given, it's 25 hertz. So that is 25, this is 50. So we put in the value here. So Fy divided by Fx. So Fy is 50 hertz. Fx is 25 hertz from the above there. This will give us as 2 waves, 2 cycles. That's why you can see 1, 2. So you can see 2 cycles. Next here is 25 hertz. So you put Fy divided by Fx. Fy is 25 hertz. We also know Fx is 25 hertz from above. This will give us as 1 cycle. That's why you can only see 1 cycle. So this is how the time base will come into factor when you actually see using the oscilloscope. What's another use of the cathode ray C.R.O. cathode ray oscilloscope? You can display the voltage waveforms as can be seen in the table above. You can see this waveform and it's useful to display voltage waveform. And in the case of suitable frequency for time base must be selected. So you can, by monitoring this waveform itself, you can monitor what kind of current is coming in, what kind of voltage is being used. You can vary the use of it. You can send different pulses. You can use for a wide variety of experiments. Next, you can use it to measure short intervals of time. So sometimes when let's say you send a sound, the sound will come back, a microphone will receive it, it will convert into an electrical signal. There'll be a voltage pulse. When you send out there's a voltage pulse, when the sound comes back, there's a voltage pulse. In between, you know what is the time because it takes time for the for this cathode ray scope for the it actually to spike again and come back down to its original position. So the time interval, because we know that there is a time space in between, because this is a time base in the x-axis, you can measure the time for the sound to travel to the wall and to come back. So you can use it to measure intervals of time. And in our topic of sound, we can use it to measure distance itself. Okay. So this would wrap up on our last topic of cathode ray oscilloscope, and this is how we can actually use it to monitor our voltage or to do other experiments. Thank you.